prerequisite when you walk around campus, because you never know when you have to go to a hill in Norway. So that's really nice. Okay, jokes aside. So in correlation with the career set out here, we decided to come today to tell you about how to land a job in the high-tech industry. And we are from Microsoft here today, but this actually applies for all the high-tech industry companies, not only in the IT business like Google and Facebook and us, but also in other big pharmaceutical companies and the oil industry. Everybody recruits this way because candidates come from all over the world, and not only from DTU. So we don't know where the candidates come from. We don't know sort of the level of the education. So we treat everybody the same and the same process we're going through. And when you look at the internet, you can also see there's a lot of descriptions of this, but you sort of get it end to end today on how we are doing this. So I'll start presenting. A little bit about what we're doing in Denmark, just for the background, but it's only going to be a couple of minutes. And then about how to proceed on getting a job. And then we're actually going to perform role plays. You can see we have a whiteboard over here. Because interviewing for a job with Microsoft or any other high-tech company is about using a whiteboard and interactively and having a dialogue. So we'll show you how this goes on. We'll do a couple of role plays on how we do this to make sure that you sort of get the hang of it. Then a couple of our latest employees are going to tell you about their experience with the first time with Microsoft, how it is to work in a global company, and how it's a big learning experience to be part of this whole new world. Like everybody else we do at DTU, we need a science show. And for that we have invited one of our most senior developers to come and create a programming science show, and he's going to show us a lot of fancy constructs where you can do really powerful stuff in C# and .NET. So that's usually it's really fun to see what you can actually do with a few code lines. So please, if it's possible, stay around to see that, because it's really an entertainment to see what's going on. So everybody knows the Microsoft brand, and everybody knows that we have Windows and Office, but there's also a lot of other stuff that we're doing that not a lot of people know about. And recently we have moved beyond and above what we're doing on Windows and Office, and you see where we also support iOS and Android, not just in the corners, but sort of full-fledged all over the platforms. We invest heavily in cloud computing. And we are probably one of the biggest hardware manufacturers in the world. We produce our own servers that we put into big containers and we put into hosting centers. We are investing big time in machine learning, looking at speed recognition and also how to mine big data and make that applicable for applications. So Microsoft is also on beat for the world of the future, and not just what we started with back in the 80s with Windows and Office. We are close to 100,000 employees, so half of them are in the US, and the rest are all over the world, spread in Europe and Asia and South America, so we are a true global company. And to prove that, our new CEO, Satya, who by the way has been to Denmark over 20 times, we know him very well. He's born in India, in a small village, and now he's the CEO of Microsoft, so anything can happen in this company as long as you really want it bad enough. Of course, Bill is still our chairman, and he's also stepping into a new role that he's going to support Satya and figuring out what to do in our new devices and service strategy. So Bill is around there somewhere, and also yelling at a lot of people like he used to do in the old days. So things are sort of like the same. Here in Denmark, currently we have two offices. We have a sales office in Hellerup, down by the Experimentarium down there. And we have the R&D site in Vedbæk, just north of here, that's direction. And total we are around 900 people here in Denmark. So these things are separated from the start, but we are really working on a new feature for us right now, where we are co-locating down in Lyngby. So they built a big construction ground you see down Kanalvej. That's our new building, but we'll only have a third of it. The rest will be stores and cafes, and there will be a lot of new apartments for postdocs and also for students down there. So this is also going to help the housing situation for students out here. But of course, our benefit is that we get closer to you, and that's one of the purposes of moving to Lyngby and not to just any other city, because we want to have a closer relationship with DTU beyond what we already got right now. Zooming down into the R&D that we are doing here in Denmark. So the R&D center is based out of the acquisition that Microsoft did of Navision back in 2002. And since that, the center has grown steadily. We are over 400 people currently, and also what's special is that we over 50% are non-Danes. So we look a lot on diversity, not only male, female, but also can we get candidates from all over the world, because we think it's really important to have this diversity of cultures when you do software for a global market. We're the biggest R&D center in Europe, when we plan to also continue to be that. We can only do that by attracting new talents and doing a lot of new things. On where we are, we opened 2 new teams doing new products last year, and we plan to continue to grow out the site in the future. So currently we're in Vedbæk, but hopefully next year in November we'll be down in Lyngby, and there will be a bike path through the railroad down there, so you can actually just take your bike and roll down the hill, and then you'll end up in our parking cellar. So and take the elevator up. So it's sort of easy to get in from DTU. So back to the whole purpose of today. So how do you land a job in the high IT industry? So I'll walk you through to what skills do you need to achieve out here, how to plan your study to get in the right position. I'm going to talk about a new internship program that we're creating, so you can sort of cheat and get in before you graduate. And then I'm going to walk you through how to prepare, how to apply for a job, the interview situation, which is really important as well. And also, when you get a job offer, what's that? It's not only a piece of paper that says you get in kroner per month, it's a lot more that you have to relate to. And then sort of a glimpse into what's the first week when you start on your desk up at our campus. So let's get started. So first of all, there's some skills that not only applies for candidates who want to get a job with us, but also applies from the employees we have, or people who apply from the industry as well. And these are sort of common human skills that you need to master and also be able to fall back on. So it might surprise you that there's nothing saying coding or computers here. It's all about human interaction, and that's really important for us in our daily work to really live up to these values. So first of all, passion is everything, and this is something that Bill, he wrote by himself back in the 70s, that you need to have passion for not only the technology, but also for solving customers' and partners' problems out there. Otherwise, it doesn't make sense what you do at all. You need to be honest and also have integrity about what you're doing. You cannot go and lie to people or your colleagues. You need to be honest about what we're doing and admit failures and correct them if needed. You have to be open and respectful in your discussions. Don't shut off people just because you disagree, but have open discussion, because only in open discussion you can have innovation and come to the best solution. And we have discussions where we have really senior people who've been with us developing code for 15 years, and we have newcomers, and we make sure that there's room for everybody, and also in the space where we let people present, that everybody gets to have their word in the saying of what we construct, because no matter how you are in career, you always have something to chip in with if you are as bright as the people we need with our company. Also, it's not good enough just to do what you did yesterday. You have to ongoing take on new challenges and big challenges. So often people in Microsoft, they move around a lot between different teams in the company. Also, some of the people with us in Denmark, they move to US or to Switzerland or one of our others to experience what's going on there, and also learn how to work in other parts of the company and the local cultures that are out there. Some of them come back, and now when they come back, they bring down a big network with them of new people. And that's really a benefit in such a big company, that the organization is totally flat. You can more or less instantly call somebody on the office team, say, why is this working this way? Or I've seen a bug here. Can you help me out? And people are really, really nice and pleasant, and reply back to you, this is what you need to do. So it's also about building a broad network in the organization. Also, the part of growing is to be self-critical. Everybody makes mistakes, and the beauty of code is that you can rewrite the code and fix your mistake. Once it's running with the customer, it's more difficult, but you need to learn from your mistake and reflect on them, so you learn ongoing on how to self-improve and what to go out and figure out in new ways to do. Also, if you have done mistake, you need to be accountable. So I created this mess, I clean it up, so there's nobody who runs away from their responsibility. Everybody knows what they did, and also if something is broken, they'll fix it. And not have somebody else cover up for them. So this is also a big part of our culture. Also, a big difference from other companies is that in Microsoft, all managers are also deep technical and can read code. So it's not like you've seen in a lot of Danish companies where you come in and you do coding and development for a few years, and now you become a project manager, and then you move on to be a people manager. In Microsoft, that's a no-go, because how can you help grow people and also understand what they do if you're not technical and can read code and understand exactly the problems that they have? So that's an ongoing thing, that no matter where you are in your organization and at what level, you keep learning and also you keep being technical. And Satya, our new CEO, he started as a developer, and he still understands what's going on in our cloud computing on devices, what components are in there, and the problems around our technology and how to relate to it. And sort of the first proof that we saw after the day after Satya got his new job, he announced that from now on we are moving all our internal tools into open source. So GitHub is going to be our new source depot system for Windows. And you cannot make such a decision without knowing what you're doing. And he definitely does, even though he's the CEO of the company. And that's what we really love about working. So going a bit deeper in your study. So you probably know there's a lot of discussion in the university work about that candidates need to be broader, and you need to know about project management or how to create a business plan. We don't believe in that, because if you need to write a business plan or learn how to do project management, we'll learn that to you later. The most important thing here is to go deep as you can in your study and make sure that you get the right engineering skills and knowledge about your domain. Because if you spread out too thin, we cannot use you. You need to have the knowledge and the depth to be able to solve the kind of problems that we need you to solve. So going out and having these extra courses is great, but it's not going to make us happy. So please don't. Also, there's a myth that if you need to work for Microsoft or Google or Facebook, you need to have a computer science degree. That's not true. We have some people with a computer science degree, but more or less the bulk of the people in Denmark are electrical engineers or mechanical engineers or people with different backgrounds. and there's also a big proof of math candidates. So as long as you can use programming as a tool to solve problems, we're perfectly okay with hiring in. It's not about programming very deep and knowing exactly all algorithms, but you need to be able to express yourself in code and solve problems using code, because everything we do eventually will end up in software. That's why we need it. But you don't need the master in computer science to apply. Also, an important part is really how to learn and communicate and present. I know you're doing that a lot out here, but it's really important for you to get your message through, that you'll be able to communicate your ideas so people understand exactly what you want to do, and also enter dialogue on how to solve deep problems. Also important to also work across domain, not just get caught in your own domain or your own institute out here, but go out and do some of these cross-boundary projects with people from other institutes, and also maybe reach out to people at Copenhagen Business School, because they know how to create a business plan and they do nothing else than that. So why not work with them instead of learning what they do and get thin on what you need to learn yourself. It's also really, really important, again, to master analytical problem solving. And that's in engineering school what it's all about. You need to learn how to break down problems and create a solution for them. Some of the solutions might be not as good as you want to, but the whole thing about breaking down problem structures is probably the most important thing, and you'll have to use in your career. I know DTU is encouraging everybody to go abroad for a semester, but I also know that very few of you actually are going abroad, but we highly encourage you to do so, because it also gives you some new input on different cultures, and also how people works different way, even though it's still a engineering school you go out to. Things are different. And also, last but just as relevant, go out and get a part-time job inside a relevant engineering field. Don't go and get a job in Netto, because most of you will be able to land a job with an engineering company. A lot of people actually want you to apply, but not many do so, because you need to find them first. But getting into a real job, maybe just 10 to 15 hours a week or during the summer vacation, really makes a difference when you come out and you know more about what it is to have a real job compared to starting here at DTU. But besides that, you have DTU's Career Center, who's also the organizer of this event, and they're doing a lot of these sessions year-round where you can get more input on how to do this. Okay, let's move on. About our internship program that we just created, so we are offering you a package where you, for the last year of your education, you will be with us. So that can either be in the end of the diploma study or at the master study. And the package we created is that there will be a 6 months internship where you do work with us. And this is engineering relevant work, otherwise DTU will not approve it. So you work on a team together with our normal employees and do exactly what they do. For that, on the master program out here, we'll get 10 ECTS points out of that. And for the diploma, we'll get 30, which is the main difference here. The other part of this internship is 6 months doing your final thesis. And here it's really important that you understand that the thesis that you're doing has to be of research value, so DTU can approve it. It's not just some random task that we figure out that we want you to do, and you go and solve the problem. It has to be something where you learn and you're able to complete your study, which is also the whole purpose of this. So this is a part of your education, not just working for us. But the benefit, of course, is that you get in and you can also really use the resources that we have internally, talk to people, get input for them, learn from other people outside the Copenhagen campus, and that also will lift your thesis and your final year out there. We'll pay you for doing this, so we haven't landed on an amount, but it will be between 15 and 20,000 a month. So it'll not be like you get when you graduate, but it's better than SU at least. And we'll allow you to take 1 or 2 classes beside this, because we know that not everybody has been completed everything. So you can take up to 10 SCS points beside this. And at the end of this, also it's, if you want to stay with us, we give you the opportunity to interview for a job with us as well. So once you're in the system, it's easier to apply for a job and also get one, because now you know more about what we expect from you. So the description of this will be on our job site. I'll give you the link for that later, but it won't be active until Friday. So if you're interested right now in knowing more, you need to go to our booth down here. We have it in hard copy, so you can read it right now. But it will be up on our internet site before the end of this week. Okay, let's move on. So how to prepare? Yeah, some people recognize these books, and so if you are studying computer science out here, you probably have this on your first year. That's more or less all you need to know about going to an interview loop with us in terms of coding. But if you forgot what it was, or you haven't had these classes because you are another part of the TU, you just go and buy one of these books and read it. It's done in a few days, and then you basically have the basics around algorithm. Another good book to read is the UML design book, created a long time ago, because that gives you some insight on how to design. So everybody out here knows how to design things, no matter if they are chemical or mechanical engineering or in electrical engineering. You know how to design things and break it down, so we know you can do that. But the UML sort of gives you a common language to sort of describe this when you go to the interview. And then the internet and also the bookstores are flooded with these interview books. This is just one of them. So there's plenty of them with cheat sheets. These sort of round up a lot of examples of what you can be asked about. But most of the time it's fairly easy, the questions we ask. It's not something where we try to trick you into something really difficult. So it's really easy to go in and prepare for this and not get caught in and not know anything about programming when you get the first question. So how to apply, whether it's for an internship or a full-time job, is that we have a special site for this, because we found out you can go to the Microsoft.com site and look at these 20,000 jobs out there, and you'll probably never find us. So we have this, it stands for Microsoft Development Center Copenhagen.dk. You go and find a job, you can submit your resume, and if you're a student, it's just a copy of your grades and also a short explanation, why do you want to apply for this job. Then if you're eligible for the job, and most of you will be, but we are seeing a lot of job application from a lot of different other peoples out there, so not everybody gets beyond this. But if you're eligible, we'll send you a form where you need to answer some questions, and also a zip file creating some task for doing a coding challenge in there, and also how to test your code. You send back the document to us, you will also get the email address, and now we read through this, and if we like what we see, and if you've not Googled all the answers or copied the text from Wikipedia, you'll probably get past this. But unfortunately, a lot of people actually get the answers from Google or Wikipedia. But we can also Google and use Wikipedia, so that's fairly easy to catch. But if you like what we see, you'll be interviewed to a one-hour Skype meeting where we'll have a developer from Microsoft asking you questions about why do you want to work for us, and also give you some small task in coding to make sure you understand what you're going into. If you get past to that, you will be invited to the real interview loop at our campus. And I'll drill into what we're doing there in a second. And this is Klaus Busk. He loves his job, so you can see that. Okay. So the process said that you will be invited for a full day, and it's more or less an oral exam for 6 hours. And before you run out of the door and you're terrified, this is actually a great experience for most people. Everything is a dialogue, so we're not trying to trash on people if they're not able to answer the question. So it's a dialogue that sort of will bring out what you know about the questions we ask you, but also it'll unveil how good you are at learning new things. And it's perfectly okay to ask questions, and also we also often give you open-ended questions. So we assume that we go in and ask, are the preconditions, are they like this, or is it something different you're looking at? So we're looking at a dialogue, not just somebody who'll go to the whiteboard and print out a solution. So the interviews are normal employees with us, so it's not psychologists or HR people that you'll meet. It's developers who are nice people. They're not going after you in any personal sense. And they know exactly how it is to work for Microsoft and what to look for. And sort of the whole purpose of this exercise is to get to learn you know you better and see if you are made of stuff that can make you succeed in Microsoft, but also to figure out your weaknesses, because everybody has weaknesses. So if you're hired for a job at Microsoft, we know where to set in and put in more education into you and what you need to learn. And if you don't get the job, we explain you why you didn't get the job and how to get better at it. So more or less, you get this free learning experience where you learn a lot more about yourself and your shortcomings in a lot of different areas, not just coding, but also in terms of communication and collaboration and the passion for what you're doing. So it's no matter what, it's a good experience. So during the interview, there's a number of things that you need to demonstrate. So one of them is coding. You need to know coding at a certain level, but the programming language is not important. So nobody really writes Ada anymore. I think it went out of fashion in the 90s. But whether you do it in JavaScript, PHP, or C# or Java or anything else, it doesn't matter. Or in pseudocode, that also applies. So don't think about, I need to program in C#. It doesn't matter, because these things change over the years as well. You need to be able to express yourself in terms of data structure. So what kind of data structure would I use to solve this problem? Algorithm, again, a very important part of doing problem solving and also demonstrating that you're able to do this on the whiteboard when you ask. And then also around the how to design things, how to break down the solution, and what kind of object structure that you think you should create to build this solution. Often we use strings as a starting point for most of the exercise, because everybody knows what a string is, independent of what programming language you know. And there's a gazillion questions you can ask about strings. So this example is a simple word count where you get a sentence and need to write the code to do the word count. But it can be all sorts of things where you have a string with a number and you need to convert it into a binary or any other string exercise. So strings are very well and do this example, and it's sort of applicable for anything out there. And as you can see, this is not a very complex problem. Most people should be able to do this, but in reality, a lot of people can't when it comes to it. in the interview situation. Another important thing is that you need to demonstrate passion. So please show that you actually like what you're doing when you're doing this. We really enjoy people who burn for doing problem solving and also talking about these issues, and that really is a virtue that we highly appreciate. If you don't show passion, you won't get the job no matter what. Also be curious, so again ask questions. So what's underneath this? There's something more that I need to know. Can I do something else to make it better? That kind of things. And also you need to again know what's going on in the IT industry. What's going on in terms of machine learning? What's the trends? What's going on in terms of HTML5? So you need to have a base knowledge of where the industry is going, because again, without that we cannot have a dialogue about what's going to solve the problems that will be put in front of you when you start with Microsoft on your first day. Also, you need to demonstrate that you want a great result. So don't go for anything mediocre, but if you're not able to come up with the right solution, come up with something, and then based on the dialogue, you need to show that you actually want to go to something better. And never give up. Keep asking if you are clueless, even at the first minute. Ask questions about this, and also show you're able to learn, because learning is again one of the key attributes that we're looking for. Okay, so enough talking. So we'll give you a couple of examples on how we do these interviews. So I'll invite some of our people to come up here and show how this is done on the whiteboard. We'll all be here after the session, so you can ask further questions on is this really what's going on, and what's the detail of this. So please welcome. Yeah.
Hello, everybody. I'm Aya, and today I'm interviewing Anka. We had some preliminary discussion about her background, why she wants to work here, and now we are just jump to coding solution, problem solving.
Hello, everyone. I'm Anka. I'm hoping to land a job at Microsoft.
Okay, Anka, let's start with a very simple problem that I have. So we have a linked list, and I would like you to discuss an algorithm with me that it can find the middle node in the list.
So the middle node of a linked list. So we have a linked list here, and middle node. First clarification that I would need. What type of linked list is it? Is it a single linked list, a double?
It is a single linked
circular?
list.
So
Good
a
question.
single linked list. And since we are asked for the middle node, do we also know upfront the number of elements in the linked list?
No, you don't know the number of elements, so it is undefined.
Okay. Let me try an example. So having a linked list with some elements inside. it's a singular linked list. It's not circular, so it has a null pointer.
That's correct.
For this specific example, the linked list has 4 elements. What would be the middle one? That's the problem.
And let's assume that C is the middle node here.
Okay, so C would be the result. So if the number of elements is 4 and C is the result, if I am counting, that would be the third node. So basically, if I would have another element here, C would still be the middle node. So for 5 elements, that would be 3. If I am to generalize, then from n elements, then the middle node will be n divided by 2 plus 1.
Okay.
And I would consider the integer part of this.
I'm fine with that. Let's have that assumption.
So in order to find the middle list, the first solution that comes to my mind would be to traverse the linked list one time. So we found out the number of elements. Then we initialize the counter to 1. And then we walk through the counter until this limit. And when we reach the middle, this limit, we return the node. This counter is on. And then we return the value from the list.
Okay, let me see. I think that can be a right solution. What is the complexity of your algorithm before we start making any code?
The complexity, I would need to traverse the list one time. So that would be O(n). And I will need to traverse the list a second time and stop in the middle. The complexity, the final complexity will still be linear, so O(n).
Okay, that's good. What about the performance? Imagine I have a very, very large list. So this should work in many situations. Do you think this is an
That's
optimized
correct.
solution?
In terms of performance, the solution is not the most optimal, as I'm traversing the list 2 times.
Yeah, that's
And
right.
it might be an unnecessary operation, so it's not that efficient.
So let's rethink the problem again. Let's think about more optimized solution. So I changed the question in the way how we can find the middle node with one pass. So you traverse the list only one time.
So if I am to progress the list just one pass, it's a bit drawback that I don't know upfront the number of elements. So I need somehow to reach to the end of the list.
Yeah, that's the point, Anka.
So I'm on a good path. In the same time, when I'm reaching the end of the list, I also need to remember or somehow position myself in the middle of the list. Something here, and this should happen simultaneously if it's just one traversal.
Okay, Anka, we need to
Can you
proceed a
give me
bit faster. What about using 2-pointer? Think about using 2-pointer.
If I'm using 2 pointers in one traversal simultaneously, then that could be one of them, the other none. And since they need to go simultaneously, this one needs to reach the end, this one needs to reach the middle, then this means that the first one needs to be faster. And how faster? Since this is in the end and this is in the middle, I think the faster pointer needs to be 2 times faster than the smaller one. So this would mean that in one traversal, the slow pointer will move 1 time, whereas the fast pointer would move 2 times.
That sounds like a good solution to me. Let's start coding it.
Is it okay to use pseudocode?
Yeah, that's perfectly fine.
I can draw the data structure that I plan to use. My pseudocode is something very close to C. So this will be the representation of a node. I have some data here. Then inside the node, I have a pointer to the next node. And my actual method would be print middle. the method would get as input the start of the list.
Yeah, you can use the method. That's okay.
And initially, I initialized the 2 pointers with the beginning of the list. So I have my fast pointer at the beginning, my slow pointer at the beginning. And the algorithm would be, while with the fast pointer, I haven't reached in the end, then progress with the slow pointer 1 position. And with the fast pointer, jump 2 positions. We reach the end. So in the end, I'm printing the information from the slow pointer, which is this one. I can test my method on the example I have provided.
I think that's a very good idea. Please proceed.
So for this specific list, I have A, B, C, D. I can keep track here of the fast pointer and of the slow pointer. So initially on the 0, on the first iteration, they are both on A. They're on the beginning. On the first iteration, in here, the slow pointer moves to B, the fast pointer moves to C. Then we are still in the loop. The slow pointer would move to C. The fast pointer will move from C to null. On the third iteration, the fast pointer is null, so the algorithm will show the correct result C as expected.
Okay, that sounds good. But I have one question, because you have 4 elements, so you have even number of nodes in the list. What about if you had 3 elements? Or you had 5 elements? So what about if it was odd numbers? Does it still work? Can you make a test for that?
Let me test. So for an odd number of elements, let's see, my list is ABC, fast and slow pointer. Initially, they are both on the first element. Then on the first iteration, the slow pointer moves to B, the fast pointer moves to C. My algorithm should stop here, but it will still continue on the second iteration because the fast pointer is not null.
Okay.
So on the next iteration, I will get a segmentation fault error here because the next address doesn't exist. So my algorithm will fail.
So maybe you should try to modify it. I think you're almost there.
Yes. In order to correct my algorithm, I need to stop earlier here. So I will need, in this case, to stop in this situation. So when I'm very close to the end on the other element, on this element.
Does it work? Are you sure?
Yes. In this case, it will stop here. Because on the C, the next pointer to C would be null.
Yeah, that's right. Any other test cases? Do you think you cover all the cases here?
Another case I can think of is when we don't have any elements in the list.
Yeah, that's good.
The loop will still pass, but the error will show here because the head of the list will be null.
But you don't show the error here. Can you correct it?
Yes. In order to correct it would be to insert, actually from the beginning, I could insert an if.
Why you didn't want to enter it in the
Because it
above
doesn't
one?
make sense to initialize these 2 pointers since we are not going to use the information.
Okay, good.
So we are not wasting. in order to treat the case with no elements in the list, I would have if the beginning of the list is null, then return an error, the list is empty, or just return empty. And as discussed before, I believe in terms of performance, this algorithm will be more efficient than the first one, because we just traverse the list one time.
Okay. When it comes to performance, any specific case come to your mind here?
Yeah, it's basically how big is the list. The list contains an infinite number of elements. For this specific problem, a linked list is not so suitable. A more suitable would be an array list, because there we have the number of elements and we can position in constant time on the middle node. While on the linked list, we need to go through the middle. So we need to have access to the memory, which is random. It's not a continuous allocation. So from initially, a linked list is not a good idea for this specific problem.
Okay, that was a good analysis. Thank you, Anka.
Thank you.
Let's move on. I would like to give a kind of a small, very 30-second feedback on Anka. I think she approached the problem with a lot of calm. She asked clarifying questions in the beginning. That's very important. She think out loud. So she kind of walked us through her thought process. And you can see in the beginning it was not optimized, but she asked for the hint. And at the moment she got the hint, she could build on top of that, which is very important. I think one thing also in her performance was specifically good. At the moment she stopped coding, then she started to test if that works with a real-life example, which is also very important that you perform that in the interview process. And then we had a discussion and we could correct the code and optimize it as much as possible. Thank you very much.
Okay, thanks, Ada. So we have another of these. So please welcome Vincent and Martin, who's going to...
Thank you.
Hello.
Hello, everybody. So you've seen one type of interview, which was about algorithm. And so as Michael mentioned before, you can have like 5 to 6 of these interviews in a day. So now we're going to show you like could be the number 2 interview, which you would have with another interviewer, and a different type of question. So we are going to do a little bit of design. I'm going to move the border here so we can avoid feedback in the... Should we turn it around?
Let's turn it around.
All right. Get some pen there.
Yeah, we're not going to design this.
All right. Okay, Martin. So we are going to do a little bit of design. I expect you're familiar with UML or the basics of it, just so we can talk about design and have some common language. So the exercise is to design a file system.
Okay. Well, the first thing that comes to mind, of course, is what part of this file system are we talking about? Are we talking about the serialization to disk, or are we talking about more API for the developer?
So I'm not interested in the low-level part of it, like you know how you read and write to the disk and all that. We assume we have some primitives in the operating system to do that. I'm just interested in seeing the API from the API point of view. So assume you're writing a library. It could be like the Java library or the .NET framework library, and you want to see the API from a user point of view, the user of that library. That could be nice and preferably object-oriented.
Yes, and it has to be like the classical file system, for Windows, like directories and files.
Yes, yes.
Okay. Let's set it up. So we would start something with UML and some kind of file system. Let's see. So the first thing I think I would consider is how we can actually generalize this, because if we are going to implement something in an update way, we need to think about the interface for this. So I might want to actually start off considering as an interface. So I have some kind of interface, let's call it file system, element or something. Like that, and then of course we have the two basic entities with this, the directory and the file.
That sounds right.
So we can have a directory and a file. So now I can't remember exactly what the notation is for when it's inheriting an interface. Is that like that?
Yeah, that's a triangle
Oh, that's
like
a
this.
full
Yeah,
triangle.
that's fine. Yes. So try to put some of the what kind of properties would this class have?
Well,
Try to mention a few of them.
so if like a directory, then of course will have some kind of parent, so it has to have some kind of root to itself about where it actually resides in the file system.
Okay.
And that will of course be one, because they have to reside somewhere in the file system.
So you are saying here that the directory always has a parent, right?
Yeah, but actually when I come to think of it, that's the problem of the root,
Okay.
because how we don't represent the root.
So how would you write that on your design?
So either we actually create a special version of the directory we inherited down as a root, and then the last one has a pointer to that, and that's a special type.
Mm-hmm.
Or we could actually just say that if the parent pointer in here or something is null, then we say, okay, that resides in the root.
Okay. But can you express that in your relation here, for example, in the cardinality here?
Yeah, you can just say it can be.
Okay.
What to say.
All right. And do you know what the cardinality is at the other end of the relation here?
Well, that will be that way we can. That'll be one, two, infinitive.
Right.
I guess because the inner folder can be multiple folders.
Right.
As we want.
That's correct.
At least from a design perspective. In a real implementation-wise, that might not be the case. So we actually have some kind of limits of this table based on how we're going to implement it.
Are you sure it's a 1?
No, you're right. There can be no zero directories in there.
All right.
Okay. So, and for the file, we of course always need to reside in some folder somewhere. So then we'll have a link. And I will leave that because it's like, it has a dependency on, like if we move the directory, the file also dies. So
Mm-hmm.
it's actually a composition where we actually have zero or unlimited files in that directory. And the file always has to be in 0 or 1 directly, because file can also be in the root. So I think that sets up how the tree of this file system actually is.
Okay. Why can you? So you're saying 0 to 1 here?
Yeah. So file can.
So that means sometimes a file is not in a directory.
That can be in the root. Actually, that was actually one thing I forgot to ask in the beginning. We are assuming just a normal file system without symbolic links and all this stuff.
Right.
So
That's yeah.
Okay. So this is basically just the classical file system. That's one copy of that file in the directory. That's what I'm assuming.
But isn't the file always in a directory?
No, because it can be in the root.
But it's still in the directory.
It's still in the directory, yeah. Where I consider actually directory as being a folder.
Okay, so you're saying the directory is a special kind of file?
Yes, exactly.
Okay.
Yeah, you're actually right with that.
So maybe you can express that in your design actually.
Yeah.
It's not expressed right now exactly.
Mm-hmm.
You have like 2 different classes for that?
I think what you're going for is that we should somehow share some of the functionality between these two. Because I guess like a move operation or copy or something like that, it's basically the same thing we have to do. Just this has to be recursive, this shouldn't be.
Right. So how can you
Yeah, I think
reassess your design with these?
I think what we should
considerations?
do is the interface, because that's just telling us how we can interact with it. It's basically the same thing for these two. So I think what we could do is actually just make a directory as a special case of the file.
All right.
Because then all the things with get name, get size, and all that stuff it resides in the file. We only actually change the logic that actually is for that's special for the directory.
All right. So is this an interface or is this a class?
Well, this will now be a class, and this one inherited that class.
Okay. Can you tell me the difference between an abstract class and an interface? Just a side question.
An abstract class can actually have an implementation, but you can never make an initialization of it. You have to inherit as a class into some other object, into some other class, before you can actually initialize it. Whereas an interface is just a definition of some interfaces. So if I say the directory is using an interface, this one has to implement all the methods that's in that interface. And the abstract class can actually define some properties of an internal data state as well, whereas the interface cannot.
All right. Sounds right. All right. I don't have any more questions for you today.
Okay.
Thank you. Thank you, guys. Yeah, so a little bit of feedback on what the way Martin. So Martin had a lot of questions about, precising question. You wanted to know a little more about what I was asking. On purpose, I asked him a very open-ended question. Designing a file system can be many things. So I expect him to ask me some precision question to clarify the task, and he did that. So that's a general thing in an interview. If you ask open-ended question, ask questions back to kind of narrow down the problems, and hopefully if the interviewer is on your side, he'll guide you along and towards the answer that he's looking for. But the purpose of the exercise is mostly to see how you think. How can you design something simple? Do you know the basic principle of design and abstraction? So it's not a very difficult problem. All right. Thank you very much.
Yep. You want to take it first?
Okay. Thank you. We're a bit behind schedule, but just let me round off on the interview process. So if you make it through the day, we'll tell you that congratulations, you're now eligible for hire with Microsoft. The next thing will happen is we'll find you a job where you're actually going to start, and we'll give you an offer letter. And then that letter basically describes the job you'll get, the job level you'll start in, your salary, which is right now is around 520,000 kroner a year as a starting salary. You'll be getting a bonus of up to 20% a year, bringing your salary up over 50,000 kroner a month. You'll get not stock awards, not stock options, but real stock that you can go on and sell. So I know people here at DTU don't care about money, but you'll get well paid as well. Of course, like any other high-tech company, we also have health insurance that go beyond what you get from the government. We have a pension scheme that you can get from day one. And also there's a lot of perks in terms of free food and coffee and drinks, and a lot of sports clubs and art clubs at our campus. Because people are working a lot with our company, and we also like people to have a great life outside. And that's just a start. We expect everybody who gets a job with us to get a career inside Microsoft. And once you start, probably after a year or 18 months, you'll be promoted to the next level, where we again learn you more, and then to the next level, and you can decide to spend your whole career inside Microsoft. But also, if you want to leave for another company, it's not bad to have Microsoft on your resume, because it's a learning experience, just like studying at DTU. So you learn every day, you learn something new, and you keep learning. That's the whole thing that we really enjoy at our campus. Okay, so next thing is that we have Martin Anker talking a bit how the experience has been joining Microsoft. So you'll hear from first hand what you're actually doing on a daily basis. Thank you, Martin. Your feet.
Okay, so my name is Martin Dam. I started actually at Microsoft only 8 months ago. So 8 months ago I was sitting and writing my thesis, as most of some of you guys probably are doing. I took my bachelor's in basically computer science at Aalborg University, but something to do with internet technology instead. And I took my master there as well. And as Michael mentioned, I actually went abroad for a semester, which was a great experience. So please do that if you have the possibility, because it's not only fun, but also you actually get to learn how you walk, like you live in an international environment, which is really helpful when you actually go to Microsoft, because everything is English. You have to adapt to how the culture is, how people make jokes, everything like that. So make sure to take a trip abroad if you have the possibility. I also put another thing as my education, that is that I did a lot of extra side projects while I was studying, and that's actually a really great way to actually try to show this passion that Michael was talking about. So if you have a project, put it on your resume, just make sure people knows about it, because that's where you really learn that you have to do something you didn't think was possible, and it's a lot of fun. My career so far, I was working as a student software developer at 2 companies, where one of them was making satellites, and another one was making mobile phones. So I tried a little different kind of work, and now I'm working at Microsoft as a software developer on the application side. It's really nice actually to have some experience working in the software industry before you actually go out, because I knew more about what I wanted, and I was able to actually put in more demands on that to make sure that the job I got was actually what I wanted. So again, I can only recommend you actually trying to do that. So why did I want to work for Microsoft? Well, first of all, I like taking on challenges, and I want to work on big problems, and that is what a big company like Microsoft is able to provide you. So that's one of my main motivations for actually working there. Further, because they have this reputation, and because they have this full screen, you know you're going to be working with smart people, and people are actually passionate about what they do. And that makes you actually better when you can work with these people. It's truly fun actually when you walk into a room and you know you're really not the smartest person in that room. You're most likely the dumbest. So that's pretty cool. But as Michael said as well, even though when you start out and you just graduated, the atmosphere is that everyone contributes to the problem. It's not the guy with the highest salary actually he decides. No, it's everyone discuss the problem and find a solution, even though you just graduated. So that's really unique, I think. Further, there's a lot of career development possibilities, for example going to the US, but just advancing internally. Also because you can actually go either the specialist way or the manager way. So if you do the specialist way, you actually can go and be in the same position as the vice president, but you're still coding, which not many companies actually offer you. And of course there's the international multicultural environment, so you actually get to learn stuff from people that's outside Denmark, which is great, especially if you're considering actually going abroad or living abroad somewhere in your career. Yeah. So how I got the job? I found a job posting on version2.dk. I applied to the normal career site, and I got to the whole scenario of answering some email questionnaire and just basically just answering some questions about what you did before and solving 2 problem sets, which is fairly simple problem, but you have to implement it and deliver the code. If you pass that, you go to a phone screen, and then you have some on-site interviews where it's basically just a day where you're talking about what you're passionate about, hopefully, which is a lot of fun. It's not as bad as it sounds, and it's just like a normal exam. You just have to prepare a little bit for it. And finally, if you get the job, of course you have to sign the contract. So, preparing for the interview, this is what I'm going to be focusing most on. I chose to actually suspend my thesis writing for 2 weeks and actually study for this, because some of these things is basic algorithms with UML and all that stuff, and that's kind of 5 years ago since I actually was reading on that. So I spent 2 weeks reading up on all this basic computer science stuff, and created a cheat sheet. It's basically just a summary of everything that I have done for the last 5 years. So the last day, the day before, I can just go through that and actually be primed for actually going into this interview. And I found that to be a great help. And also, if this interview doesn't work out for you, then you have this cheat sheet for the next one. So always a good thing to actually get this done. Besides the technical part of that, I of course studied the company. What is Microsoft? What is their challenges? What products do they offer? What are they working on here in Vedbæk? Who are their competitors? All these things. Just try to get a sense of what we're actually working with. Because if you go in and they ask, you know what we're doing here, and you have no clue, that's really not showing that you're actually prepared and you're passionate about getting this job. So just do you a favor and spend an hour or something reading up on this. And of course, I did a little familiarizing myself with state of art for this area as well. Just what is new and what is going on. There's some great articles you can find about this stuff, so spend some time with that. Because this type of thing actually just helped me to do my thesis as well, so it's recommendable. I know Michael said that you shouldn't necessarily write in any Microsoft language, but it always helps to know the difference between the language so you can actually discuss this when you go into the interview. So please know more than one language, because then you can say, oh, maybe I don't want to use MATLAB to do this satellite project. So know two different languages at least. And finally, try to do one of these practice interviews with friends, because it is a lot more difficult actually standing on the whiteboard in front of a person actually trying to do this interview than you think. So just try it out a few times and until you get comfortable with it, and then it's like talking to a friend when you actually go to the interview. So that actually takes a lot of pressure off. Yeah, the interview, this is what I found from it. The purpose is to see how you approach solving a problem. You're not supposed to solve an NP problem in 10 minutes. That's not the case. You just want to see how you think and how you actually interact with this problem, as we try to demonstrate today. And some of these questions might not even have an answer. It might be put up so vague that you have to answer questions, and that is the actual question, that you're able to ask the right questions. So maybe you shouldn't be able to solve it. You should just be able to actually analyze it. That could be one of the questions you'll get. So just think about it as you're about to solve, and don't try to jump directly into code, because that shouldn't be the right way you actually do it in real life. Yeah, and then one of the things I learned at least was try to consider other things than just technical and we want to optimize it for this linked list or something like that. Think about who else should use this product. What are we using it for? Think a little about in the context of what we are doing. And that'll help you ask these questions that you actually should be asking. Because in the end, what we need to do is we need to ship this product to a customer. So being able to consider this in the interview will be a good thing to show. And the final thing, you will be challenged, so don't be worried, don't be afraid if you actually can't answer one of the questions. The point is to try to find where your limit is and see where you're not so good. The purpose is to see how you act, how would you actually go about solving this problem, because inevitably you will find a problem where you cannot figure it out just on the top of your head. So don't be afraid of if there's actually a challenge and you can't answer it. So, and just talk a little about my transition from being a student to being a full-time employee. It's really nice to see that your education you actually spent 5 years on can actually be used in real life, and you're actually being able to do that from day one. There's no dummy task you have to do, something like that. You just, here you go, here's a task, get it done. You will of course get a mentor to help you in the beginning, so you don't just fumble around in blindness, but you actually get to work from day one, which is really nice. This is one of the things I really learned as engineering. We tend to think a lot about math and algorithms and stuff like that, but it's not just theoretical. We also have to consider the people and the business we're working with. So getting that skill already up front will be tremendous, beneficiary for you to actually have. But otherwise you'll figure that out when you actually go out and get a full-time job. Great thing, there's no homework. But there is some other kind of responsibility, because now you're responsible for the things you're producing, and you are off in the night, but you sometimes need to think about a problem or something when you're home. But that's not the classical homework reading 20 pages for the next day, which is great. Yeah, and ramping up, easy. You have an inventor, and there'll be an entire plan for you. Michael asked me, had the plan up here, but we don't have time to show it. And they'll guide you through the process and getting you up to speed right away. It's a welcoming environment, and we have a football table and a game room where we actually have fun, and that makes it just, you feel like home right away. So, really nice place to work. Plus there's free soda. So, and just to wrap up my daily work, what I'm doing is I'm working on something called Dynamics NAV. It's a business product, so maybe you haven't heard about it. But basically it's a financial systems. What I'm doing is I'm doing the implementation to ensure that the product is legally compliant in all our countries. And plus, I'm doing some tooling for some optimization of our processes. For example, some merges and just trying to optimize what we do. And the great thing about it is that if you actually take your responsibilities and do them perfectly and show maybe you can do a little bit more, well, that's just Microsoft going to hand you an even bigger challenge. So you'll never run out of work and you'll always be challenged in your work, which is one of the benefits of actually being of such a big company. And my advice for building a career at this point, although I've only been there for 8 months, is just do your job really well. Learn how to have influence in the company. Learn how to talk to the right people. Don't just assume that you know the answer. Go out and talk to people. Do the job correctly. And also have side projects, as you probably did when you're probably doing right now. And if that side project turned out to be something great, then you might become part of your responsibilities. But otherwise, you just learn something about a new technology. So keep your passion when you go out in the industry, not just work from 8 to 4. Actually have fun with it. And that's what I had to say.
Hello everyone. My name is Anca Roxana Ciocan. I'm a software engineer at Microsoft, and I am here also to share my experience about working for Microsoft. So something about me. I'm from Romania. I have a bachelor degree in computer science and engineering. I graduated from Polytechnica University of Bucharest, which is basically the DTU from Romania. Immediately after my graduation, I came to Copenhagen so I can start an internship with Microsoft. I was part of the ISTEP program, which was a full-time internship, something that Microsoft was offering in that time. I stick to that program for almost 1.5 years. Afterwards, I applied for a software engineer, full-time position. I went again through the interview loop, and I got the job. How it all started, how I joined the first time. I was in the last year of my university. I was very anchored into the academic work, preparing my project thesis, having a part-time internship on the side, keeping up with the task from school. But there was this huge green poster, the version of Do You Speak Code from then, and it seemed like so appealing to me. Basically what it says, it's not so clear, is if you are a type of contributor person and you want to make a difference, you want to develop software for global, you want to impact millions, then come apply, join Microsoft Copenhagen. So this was the main trigger of my application. I put a lot of brains into my application. I prepared something like Martin just explained. I put a lot of enthusiasm in my letter of intention, basically explaining why I want to join Microsoft, what's my passion, what's my curiosity. And of course, emphasize in my CV most of my strengths and relying on them. Microsoft get back to me. I had to solve a similar set of problems via email. I sent my results, they were okay. So I got scheduled for an on-site interview. Basically, Microsoft was coming to Bucharest for a recruiting event, and I was part of that event. I got the loop, something similar with what you have seen so far, and I got the contract. After graduating, presenting my diploma thesis and having the summer vacation, I came to Copenhagen. I came to the campus, I get my blue badge, and I got to know the campus in Wielbeek. So that's in short my story about how I joined. Why I joined Microsoft? Initially it was just curiosity, how it is to work in such a big company. I didn't have so much an idea of what a career is because I was fresh from university, not so much work experience, but I was very dedicated to solving technical problems, and I know that high-tech companies is the place for it. So my passion for technical problems sticks. It's still alive. Most of all, working with smart people. Of course, you are challenged and you like to have your own discussions in the classroom during university. But my period staying at Microsoft as an intern helped me have a more insight into what's the Microsoft culture, how it is to work and what do we do there, how we collaborate, how do we interact with each other. So working with smart people is a great benefit because you have the sharing knowledge. Everyone is willing to help you. Basically, it's a living encyclopedia on the Microsoft hallways. You get the answers that you need from the people around you. Being part of a multicultural environment. The cultural background models our insights, so you get to have different insights when you look at a problem based on this. It's also fun because you get to know a lot of customs, how people from all across the globe celebrate different holidays, so it's a fun fact. Spending time in a nice, fun campus. You overheard, the campus in Wilbeck is great. We have the nature around. The new campus is going to be even greater. We have free Coke, free coffee, super delicious food. It's lovely. The most important, if you are passionate about technology, you want to be the first in line to deal with innovative methodologies, and I'll explain more broad in the next slide. You want to be the first one to try the software, the new software, the updates, the latest Windows 8.1, for example. And you want to interact with the newest Microsoft devices. So being an employee at Microsoft, you have the perfect chance to do this. And having all the technical problems, the challenges in place, having the people to rely on in terms of sharing knowledge and getting help, learning from them, as well as having the tools, the innovative methodologies, knowing about them, all these help you become better. So it's a continuous development. You keep learning, you continuously become better. This is a set of excerpts of Microsoft tools that we use at work. Of course, we program in Visual Studio, we use PowerShell, we use Windows Azure. Most of our development boxes are Windows 8.1. The open community where you are free to develop your project and attract people which are interested is the Garage. Most of the tools from the Garage go to Toolbox. Us as engineers use the tools from Toolbox to increase our productivity. We have a wide access to Engineering Excellence Center, which hosts a wide variety of tech talks recordings, so we can access them afterwards. And also there are multiple trainings and tech talks organized in the campus. So that's a great opportunity to keep up with the technology and learn new stuff. As well as we have MS Library, where you can just borrow books. They get shipped to the campus and you are free to read them and return them when you're done. What do we do at work? These are part of the methodologies that we are trying. We have a process, we are agile. We have a product owner, every team has a Scrum Master. We have our backlog with the features that we want to implement. We order them based on priorities. We synchronize and have a lot of collaborative projects, let's say. We do stand-up meetings every morning where we present our status and what is actually blocking us if we need help. Grooming meetings where we envision what would be the solution to fix a certain problem as a feature. We do planning, we do retrospective in order to continuously improve our process. In terms of coding, when you are checking in new code into the new product, then you have a gate. And this gate makes sure that your new code gets built with the old code, the code that resides already into the product, and then a set of tests and some verification steps are run. So this ensures the integrity of the new code into the whole system. As methodologies, we do pair programming. We share each other experience from different areas of expertise while coding, as well as we send code review to get feedback from people who know the areas or get feedback about the design of the solution that we have implemented. So it's not a secret what you code. We apply test-driven development wherever we can, and then we do a lot of scenario testing. So besides implementing features, we also ensure that we have a proper gate in terms of automated tests for our scenarios. Quality metrics. How do you measure that the code that we develop is in the right quality boundaries? We look at the test automation rate. We also look at the numbers generated from the test coverage. We do risk analysis where we look on the buggy areas and how much testing coverage they have. And we assess the scenarios, the features that we got through overall gut feeling. How do you feel about the experience from user's point of view? Where can we do this? Either in our daily enlistment, synchronized enlistment, or we produce daily builds. How do we get feedback of what's happening into the outer world? Us as developers are not as clustered as in a box. Basically, we have our sales-product interaction where we try our features, or we do cross-team testing where we get to learn and try the features from another team. As well as end-to-end testing day at the organization level, when we try a scenario from the very beginning to the end. That can be a large scenario. From the point of view of the customer interaction, it is very important to keep in mind that when we develop a feature based on the person that is going to use the feature. That person has a certain skills. So this is a persona for us. And when we have a feature, we develop a feature to solve the problems of that persona. How we get to meet? We also get to meet the partners, or at least find out of how they use our solutions. So that's also interesting insight to have in matters of how our product is used in the out world. Also at work, we have great parties. We also have organizational-wise team buildings where we build not only code, we also build cars and the bridge on top of the lake that's in the campus. We have every spring new residents, the ducklings on the pond. And we have an open community where you, as Microsoft employees, you can subscribe and you benefit from massive discounts to different events. So through this event, I got to play tennis, I'm running, I got to learn swimming, I'm going to the cinema. It's really cool opportunity to interact and make friends with your colleagues. To conclude, for me, the experience when I joined Microsoft was a total life change. But I put as much passion into it as I could, so this turned out to be good enough. Every day you have a challenge. You need to come up with a new idea or a way to solve it. And you only do this through collaboration with your peers. So this keeps you anchored into everyday work. Everyone around you, your colleagues, your friends, are from different parts of the world. You get to learn a lot from them. You are dealing with latest devices and technology. And overall, it's a continuous development. You everyday growth, professionally and personal. So that was my experience. Thank you.
So just give me a minute to set up here. So, hi there. My name is Thomas. I'm not here to share how I got a job at Microsoft. Instead, I'm going to give a tech talk, one of these talks that Anka was talking about before that we do once in a while to kind of educate ourselves, become smarter, and so forth. Now, this talk, I kind of cheated because I've done this talk before. It's a big task to kind of prepare for all these talks here. So this talk is going to be about some of the problems you have in multi-threading, how do you control multiple threads and so forth. But the good thing about this talk is that you can listen to this without knowing anything about anything. And I also have a bonus on talking a little bit about LINQ and demystifying that. LINQ is a construct of the C# language, which is extremely powerful if you master it. So let's get started on the mechanics of multi-threading in general. And the interesting thing here is that multi-threading or multitasking just means that we are doing multiple things at the same time. It doesn't necessarily mean there are multiple CPUs or there are multiple parallel streams or so forth. It just means doing multiple things at the same time. But that was actually impossible before we had multiple CPUs or hyper-threading CPUs and so forth. So in the old days, you actually did
have multiple threads, but you only have a single CPU to do it. So it doesn't mean that they are running at the same time. They can get time sliced and run a little bit, first the first one and then the second one, and so forth. We have some concepts here. Initially, we have the process. Whenever you construct a program, it doesn't really matter which operating system, but I'm referring here to the Windows operating system. So a process is a harness of all the threads that goes into that application. It's a harness of the memory allocation, whether it's physical or virtual, really doesn't matter. The addressing of that memory resides within that particular process. A thread, however, is an execution harness with an individual stack. So you can have multiple threads going on inside a process. They will automatically share the memory, so you can pass on a pointer or a reference from one thread to another thread, and they will both be able to access that particular piece of memory. You cannot, however, pass a pointer from one process to another process because they are in a separate virtual space. So you need to kind of have communication methods or other means of passing information from one process to another. When we are talking about multitasking, we can do it in two ways. Either it can be cooperative, meaning that everybody works together on this, kind of using some CPU time and then give away the control to the next one in line. Or it can be preemptive, meaning there's a timer that kind of slices up the CPU power among these threads and so forth, and you get your time without you being cooperative about it, or both. And the interesting thing here is, if you look at the way the good old Windows operating system was done before we had multi-core CPUs, before we had multiple CPUs in the first place, there was only one thing going on at once. At all times, there was only one CPU executing one thing. And the core thing of the Windows operating system, and it still is, by the way, is what we call a message loop or a message pump. So basically, you should imagine the one thing that goes on executes this loop. And this basically asks for, are there any things that I should do? Give me the next message in this queue, the next work item, the next thing to do here. Well, when I got that one, I translated into what I need to do, and then it dispatches. This is basically calling out to somebody who subscribes to this particular thing. So imagine that you're clicking a button. That will be picked up as a message saying he clicked a button, and then you will call the unclick method, basically. Now what happens if the unclick method then just goes into waiting, do nothing, long and lengthy process? That means that the message loop is no longer executing, and that's where you kind of see these UI programs that's kind of hanging, not responding. You know, the not responding in the title basically means that the message loop is no longer executing. Somebody janked out here and never returned, and then you're kind of, in deep shit, so use popular word here. Because you no longer can do anything. Now a better design would be to call out, start another thread doing the work, and immediately return to the message loop, which is some of the things that we do in the modern programming world. Now all this thread to which the message loop is sitting is called the UI thread. If you do Windows form programming, you will have special capabilities of the UI thread, because that's the one where the message pump and message loop is running. Now, preemptive multitasking. That means that the operating system now starts switching between threads without you kind of knowing it, without you being cooperative about it. And the problem is, if you do that and you're in the middle of something, how do you make sure that somebody else does not, start doing things with the things you're doing things with, and so forth? And this is what this talk is going to be about. The good thing about this preemptive multitasking is that you have the capabilities of doing the full CPU utilization. So if you have multiple CPUs, multiple hyperthread CPUs and so forth, you can have multiple threads going on because your application is designed to work with multiple threads. Then it doesn't matter whether these threads are kind of executed by one CPU or executed in parallel by multiple CPUs, as long as you make sure that the data they're processing is kind of treated with respect to each other. And this is where I've come in here saying multiple threads require synchronization. And this is actually where all the complexity and the fun begins. And I'm going to look a little bit into that. So synchronization is all about protecting non-atomic operation. And let's talk a little bit about atomic operation. What is an atomic operation? That is something that kind of happens in one go. Kind of poof, it's done. And this one here, n equals n plus 1. If you look at this code here, there's an n equal n plus 1. I'll explain the code in a second. But that is not an atomic operation because the underlying processor will kind of go to the memory, find n, add 1 to n, and store the result. That's actually 3 operations. Or you can do an increment this memory cell, but it won't be one atomic operation that can't be interrupted or broken down. And what I do here in this example, very simple program. It starts up 2 tasks running this add number. So it actually starts 2 separate threads. This is the main thread. It starts 2 separate threads, which just a million times adds 1 to n, which is a shared variable across both. Now one would expect when this runs, and then the program here waits for these 2 to complete, and it prints out, I'm done adding, and one would expect that you get a 2 million here. Unfortunately, you don't, because what happens is that the first thread will kind of read n. Then the second thread at the same time will read n. Both of them will see the value 77. Both of them will add 1, and both of them on top of each other will store 78. And you kind of lost one of the increments here. It's extremely simple, but this is kind of one of the reasons that you see bugs in software, because nobody kind of anticipated that 2 threads would be operating on this guy on top of each other, thereby leaving a bug here. So this method is known to be not thread safe, meaning you can only execute this method in 1 thread at a time. So you need to protect yourself against this one being executed in multiple threads. That's extremely important. Calling non-thread safe from multiple threads is dangerous. I mean, you are in no land, you don't know where you're going. So to fix this issue, we basically need to change the n equals n plus 1 down here and put in another construct. And luckily, we do have constructs. This is C# code, and this is using the .NET library. And inside the .NET library are a lot of methods which kind of make sure that you get an atomic operation when you do this particular thing. This one uses the interlock increment. That basically means that it freezes the CPU while it's increment this particular variable by 1. And that is a core principle of the primitive operation, that you can increment something as an atomic operation. The important thing here to realize is that this n, the type of the n, can be integers and words and bytes and so forth, but on a 32-bit processor it cannot be a 64-bit integer, because that would kind of require 2 operations to do that, to check for the overflow into the next 32-bit integer and so forth. So that would render this one non-atomic. So the baseline of all multi-threaded control is to be absolute sure that you have atomic operation. And from there you build all the other things that you need, locks and semaphores, and I'm going to move a little bit into that. So how does the atomic operation get guaranteed? And that is one instruction in the Intel processor. There's one instruction that is guaranteed to be atomic, and that is that exchange instruction here. So basically, this assembler instruction exchanges this register with the contents of a given memory address. This is guaranteed to be atomic. Nobody can change neither the register or the memory in between. These 2 are exchanged. Now the interesting thing is that having this single instruction, from there you can build all the artifacts we need to control multi-thread programming. Of course, this has been built into libraries, but it's important to understand this when you do, ERP products, as we saw before, the Microsoft Dynamic Nav, as I and all the other guys you've seen on stage are working for. We think multi-threaded, we think problems, we think what happens if somebody changes this, meanwhile I'm doing Now, all these kind of things is something that you think about. And it always relates into business and normal scenarios like, let's say you're a salesperson, you have somebody on the phone, he asks, can I get some bicycles? You go check the inventory, yes, there's 10 bicycles. And then he says, okay, so I would like to buy 8 of them. But meanwhile, somebody sold, 5 of them and so forth. This is kind of one of the problems that we're thinking about. And it all stems down to being able to do this exchange. And let me show you what I mean by that. If you think about this, you want to do an atomic add operation that we had before, the n equals n plus 1. How can I guarantee that will work by only having the exchange operation? I coded this manually here. There are a better way to do this, but to kind of explain the thing here, what happens is we have the exchange operation going on here. So what we do is we read the current value into a value before. Then we do a value after by adding the add we want to add. Let's assume somebody is messing with this meanwhile. So the other thread will also have read the value before at this point. Now we call value replace, and that basically exchange what is in here with this one and return the old one into the value replaced. That is a simple exchange operation here. So we fit the new value into the register, exchange it what was there already. And the interesting thing is, then we check whether the value after the calculation we did actually ended up being the thing that, no, sorry, the value before, the thing we base our calculation on, is the same thing that we actually took out, meaning that what we did as an atomic operation, nobody messed with the results in between. If not, we just loop and do it again. And then 5 threads can do this at the same time, and eventually all 5 will have their addition being done because they check at the same time. This is of course not the way to do it. This is called a busy way, but this is kind of like showing how you could do it, and all by means of this interlock exchange. Another way that another thing we use often is we use a lock instruction, and to do a lock instruction with an exchange, you basically do the same thing. You exchange a variable with a 1, and then you check that I got the 0 back. Right? So you expect the 0 to be there, you exchange it and check that you got the 0 back. If 2 threads are doing this at the same time, one of the threads will be replacing a 1 with a 1 that the other thread put there, and now you can detect I'm not the guy who got the lock. And you can loop or whatever you want to do, but that gives you a way of doing a lock and then do 5 statements. Right? So you can do your own atomic operation by protecting this via a lock, which operates on this very primitive atomic operation in the body. Now, the interesting thing here is that all the variety of synchronization techniques and so forth are voluntarily. There's nothing in an application program that forces you to go ahead and grab a lock before you do some code. If you forget, most likely it will work until the point where another thread messes with it at the same time. And now you'll have these random bugs that happens once in a while that are really terrible to find. One of the worst things to debug is to debug multi-threaded program that has these random occurrences of bugs. Really terrible. But let me talk about something from the real world that we all know. I'm warning you, now we move into the real world. It's no longer academic talk. So, think of a bathroom. Anybody here knows a bathroom? No? I never did this DTU before, but I would assume that you guys know bathrooms. But anyways, you did. This is a bathroom. No, this is not a bathroom, this is a toilet. Anyways. You should think of a bathroom here with a wooden lock. So we kind of do a contract, a voluntarily contract that outside the door of the bathroom, you have a wooden pass. Whenever you go into the toilet to use it, you take along with you the wooden pass, okay? You do what you have to do in there, and when you get back, you hang the wooden pass, and that will work fine as long as everybody is adhering to the contract. You with me so far? It's a very complex science. All right, so let's see this, in code. What would it look for? The biggest thing here is, of course, we have one requirement. Obviously, we like to get this one right, because if we mess with stuff here, we will have trouble. So I kind of written a small C# program here that kind of use bathroom. It starts by taking a lock. You saw the lock before, that ends up doing an exchange. So what we do here is other threads, when they reach this place here, they will block. They won't execute any further until we do whatever we have to do and end here where the lock is automatically released. Okay, you with me so far? So this is interesting. You can do a lot of these locks. It's very fast to take an uncontested lock. That's super fast. So you can do millions of these within a second. So it doesn't slow down your program significantly to do these locks. Now, the interesting thing here is that the lock keyword in the C# program is what we call syntactical sugar. Behind the scenes, what really goes on is this. This is basically what the C# compiler will rewrite my program to look like this. It uses a construct called a monitor. But monitor.enter means I want a lock on this object, and please return a boolean whether I got the lock or not. And without a timeout, this will block until I get the lock. And then you do what you have to do, and finally, if I got the lock, then exit here. And you can ask the question, why do you need this Boolean construct? Because if I block until I get it, won't I be in a situation where I always get the lock? And the answer to that is no. Because if you have a thread that gets aborted, somebody suddenly aborts that thread, this call will return because it's kind of blocked, but it will return immediately with an exception, but this one will then be false, which is why you need this construct. But this is what the C# compiler actually rewrites this into. This is much nicer to look at, but this is what you get. Now, let's play out this and do this. The problem here is that you see, kind of overstep myself here. So, the problem is now the following. I'm sitting in the toilet, right? I have the wooden pass with me into the room, and I discover there's no toilet paper. Do you know what toilet paper is? Okay, you don't know a toilet. We do know toilet paper. That's interesting. Anyways, so I'm sitting in here. I have locked. I have the wooden pass, and now I discover that I don't have any toilet paper. Luckily, there's an emergency phone in the booth here. It's a pretty special toilet. So I call the janitor and tell him there's no toilet paper here. And he says, oh, I'll bring it along, and I'm happy, so I wait for him. And wait, and wait, and wait, and wait. The problem is, you see the code here. He's waiting outside the door for the wooden pass because he cannot enter the room while the wooden pass is not there. And I'm sitting in there waiting for toilet paper with the wooden pass in my hand. So now we have kind of what we call, a deadlock situation. We are not getting anywhere here, right? The code here, you see here, I start by grabbing the lock, then I go into a loop saying while the toilet paper amount is 0, call for janitor, and then wait for a couple of minutes and then check whether he magically filled out the toilet paper, which of course is not happening because his routine down here, fill up toilet paper, will try to grab the lock, but the lock has already been taken. This is one of the typical deadlock situations you need to figure out what to do about. So the fix is actually to do something like this. Well, first of all, you should never ever do a sleep while you have a lock. The important thing here is you're grabbing a resource and now you're waiting for something else to happen. You should never ever do that if by all means possible to prevent. Now the fix here is to use a capability of the monitor construct. You saw the lock that we took before actually was a syntactical sugar for calling a class called monitor. And what you can do, you should imagine that in the real world here, while we're in the booth waiting for toilet paper, we basically throw out the wooden pass to the outside. And then we wait for somebody to throw it back to us. Right? So after we've done this, the monitor.wait call will kind of release the lock and wait for somebody to signal you can try to take it back. And this is exactly what's happening here. Now the fill up toilet paper of the janitor, he will wait until he can get the lock. And suddenly he can, because after we call here, we release the lock, he can now get it, add some paper, and then he calls something called a pulse, meaning all threads that are waiting on this monitor will appear and try to re-grab the lock, which means I will loop around, discover that I now do have toilet paper, then I can do what I need to do and then release the lock. You with me so far? This is extremely important because this is a way of having two threads, even though the code is next to each other, it's executed on two different threads at the same time. And you need to be able to control exactly what goes on and who does what when you have these multi-threaded issues.
You can do this two ways, recursively and non-recursively. If you do it
So-
recursively, it's very simple. If n is equal to 0,
What we call here is, we call this a pulse wait pattern. So, we just summarize here. The monitored wait will release the lock I grabbed and then wait for a pulse and then re-grab the lock before leaving the state. So when I get out of this call, that basically means temporarily in here I gave away the lock and I got it back before leaving here, but somebody else could do something in between. At the same time, by doing this wait, I relinquish the control of that CPU doing my thread. It can do other things. It might be minutes before he fills up the toilet paper or whatever. So it's also very economical from a resource perspective. You have other calls on the monitor. You can call exit, which release the lock. You can call is entered to figure out whether I do have the lock on this statement and so forth. Now let's try to look at what we should do and never should do here. First of all, global locking needs to be done in the same order. Imagine another scenario where we're operating with two different locks. So I take lock A, and then I need a resource protected by lock B. So I take lock B and everybody's happy. But if you have code elsewhere that does this in the reverse order, if I take lock A, another thread does take lock B, and now they both want to take the opposite, they will again wait for eternity for each other. You need to be able to control that. You need to know exactly which locks you have in your program. A good way of overcoming that problem is, one, do not have multiple locks. That simplifies the problem to a very great deal. If you do have multiple locks, make sure you sort the order of which you're taking the locks. So basically saying you can never take the B lock without taking the A lock first. If you do that, then you will avoid the deadlock situations. Don't do time-consuming operations while holding a lock. That kind of makes sense, right? If you're sitting there and you are, doing stuff and you are having a lock, nobody else can access that resource, so you should grab the lock and release it as fast as possible. And of course, think about the deadlock. If I were to give one advice, this one would be the most important one, because this is where we spend all our time debugging and do stuff. If we get this one wrong, it's really terrible. Now let's look at something else. This is actually a piece of code that we had at once in a framework we did at Microsoft once. It's not that great. I actually categorized it wrong here. Let me walk you through what it really does. Somebody decided to do a cache of pictures. So I need to load some from a file, I need to load, let's say, a bitmap. So I have a dictionary, which basically gives me a lookup mechanism from a string. I can get the picture. And I start by locking the cache. Good design. I lock the cache because while I'm looking into it, somebody might be adding stuff into it. And the cache itself is not thread safe, meaning I need to protect the access to the cache by a lock. That's a good design. Then I go cache try get value, meaning look up the file name and give me the result you found in the cache. That one will return false if I didn't find anything. So if I didn't find it, then I load it from a file and give my result. Now I loaded the picture from my file, and on the way out I put it into the cache and then I release the lock. Now the problem with this design should be obvious from the rules before. And basically this is, I'm having the lock here while I'm doing the load from file. And this basically means that while I'm loading this, which happens to be a network resource file or something that takes 5 minutes to load this file, I'm having a lock in the cache preventing anybody else from doing lookups into the cache for a picture that might be there. You see this problem? So basically what we need to do is we need to make sure after we figure out that this picture is not in the cache, then we need to release this lock while loading kind of offline, and when we are done loading, we can put it into the cache again. And this is what this code does. should do. There we go. So this one is what I call better. What we do now is we take the lock, we check whether we could find it in the cache. If we could, okay, return it. We are done. No problem, we found it, everybody's happy. If not, we release the lock. Meaning at the second we release this lock, all the other threads doing lookup into the cache at this point can do their work. We're not blocking them anymore. Then we load it from file. And when we are done loading it from file, we relock the cache again, because now we need to insert it into the cache, and we need a lock to do that at the same time. But we need also to take care of what happens if exactly two threads at the same time do a lookup for a bitmap which isn't there, the same bitmap. Both of them will end up loading it from a file offline. And both of them will now try to regain the lock and insert it into the cache. And that will yield an error, because you can't have the same thing twice in the cache. So after you loaded it from the file, you grab the lock, and then you check whether by magic it's in the cache now, because another thread could have put it there. While you were loading, he was faster than you loading the same thing. If so, we just ignore it and return the thing we found in the cache, and the thing we loaded, we just ignore that and throw it away. Otherwise, when we're done, we put it into the cache and then return it and release the lock. This is a better design, and it has another side feature here where you might have noticed that if the load from file fails and saying I don't have it, I'll get a null out here saying the item isn't there. But I'll put the null into the cache, meaning I'll cache the situation that I do not have the picture at all. That was not part of what we had over here, where you have a problem where you potentially might check the disk every time for not there. There's only one problem with this piece of code, and that is, let's say this one was a paid resource. Whenever I try to load something from that external storage or whatever it might be, I pay for it. I do not want to pay twice for loading this particular bitmap just because two threads at the same time were doing it. So instead, I would actually like to control this and optimize it into only one guy loading this bitmap before putting it into the cache. You with me? All right, and that can actually be achieved by a little bit better design, where you, after you discover that it's not here in the initial phase, you insert a picture which is not loaded as a state. So while you're grabbing the lock, you do a memory-only operation, inserting an empty picture, and then you release the lock. Then afterwards, you check offline if the state is not loaded, and if it's not loaded, you place another lock, but you place that on the picture itself, meaning that two threads will now be blocking here, trying to load the thing from disk. And then after you get the lock, you check again whether it's not loaded, and this will be the other thread will now have loaded it for me meanwhile. And then you set it in, the rest is the same thing. So this is actually one way of working with constructs to do multi-threaded programming on real scenarios. This is code that's actually in our applications. Now, this monitor construct that I've shown so far has some limitations. It's extremely fast, but it can't do synchronization cross app domains or cross processes because it uses a memory construct to synchronize. Basically, it just wraps the exchange instructions you saw before. So if you have another process, you can't have another process releasing the lock that I took because it's based on some memory that only exists in my process. Also, only the thread that acquired the lock is capable of releasing it again. This is actually extremely powerful and extremely convenient, but in some scenarios it might be very inconvenient, but I'll show you ways to circumvent that. Monitor is extremely fast, since it's something that just touches memory, but it doesn't offer anything like counting. Like I have a shared resource where I can have 3 guys doing something at the same time. How do I implement something where I can count to 3 and thread number 4 should block? And of course I can do that by just having a lock, and then I can do my other counting mechanism on top of that, but it should come out of the box, but then it's not monitored, it's another construct we need to use. And again, another thing here, Monitor does not support waiting for multiple locks. Let's say I want to, in the A-B scenario before, I want to be able to grab both of them at the same time or none of them. That's a typical scenario you also run into. Monitor does not support that at all. So we need to use other construct if we have these complex scenarios. And there we have all these things here. We have a mutex. A mutex is offers the same functionality as a monitor, but it can do it cross-process on the cost of performance. It's a little bit slower, but can do exactly the same thing. Whereas a semaphore is more complex. It does both cross-process, and then it does a number of concurrent locks. It kind of does counting, where you can have these 3 guys can do the same thing, and so forth. And you have reset events, manual reset event, and countdown events, all kinds of variants of these constructs that allows you to do special things, and I'll show you some example of these. So let's look at the mutex class. This is a very simple way of making sure your application only runs once. Let's say you have an application on Windows, you start it. When you try to start it once more, instead you get the one you already got. This is a typical scenario. And this is actually done by using a mutex. Remember, this is cross-process. So instead of locking an object, you lock a string. Any string will do. It really doesn't matter. You lock this unique name here, right? So what happens here is in the main process, you try to take the lock on this particular mutex here, and if you cannot get it, that means somebody else, meaning the other instance of your application, grab the lock. And then you just do, only one instance, press enter to quit. Otherwise, you got the lock now, and then your application can run, and when your application ends and this one gets released, the lock will be released as well. That's one way of using this mutex, which does a cross-process lock, so only one can get this one. If you look at the semaphore class, it's a little more interesting. What I implemented here is a scenario where, just like a discotheque, there can only be 3 guys at this bar at the same time. They can enter the room, but they cannot drink at the bar. There's only room for 3. That I can do easily with a semaphore. I'm allocating a semaphore here. The first parameter tells me how many seats do I have in total, 3, and how many of them are free to begin with, also 3. So I'm creating a semaphore allowing for 3 things. Now then I have my main program that 5 times starts a new thread, and the new thread kind of just write out here I am, so forth, and then it calls a max 3 in bar dot give me the lock. The first 3 of them will get them easily. Thread number 4 will now block here. The other threads, after having done I got served at the bar, that takes a second, and then I say I'm exiting out of the bar, and then I release my lock. Immediately when I release the lock here, number 4 now can be served, and then eventually number 5 at the go out. If we see the output from this program, it will look like this. So you see number 1 is in. Number 1 got served because he got the lock. Number 2 gets in, number 2 got served, 3 gets in, and 3 gets served. Number 4 gets in, but gets blocked here, trying to get the lock. Same thing happens with number 5. He gets in, but doesn't get served. And then at some point, number 1 is exited, and immediately at the point where number 1 is exited, number 4 gets served, because now he gets released, and so forth. Are you with me? Have you been thinking about multi-threaded programming like this? Think about all this, what happens if, and so forth. It's really interesting. And these constructs about semaphores, mutexes, really can give you a lot of help doing this correctly. There are also complex lock constructs like a reader-writer lock, where you start, accessing things for read-only purposes, and suddenly you decide you want to do write-only, not write-only, but write purposes as well, and so forth. All these constructs are extremely complex to implement yourself. So if you can find them in a framework, that is typically the way to go. Now, the auto reset event and manual reset event, these two should basically be think like a turnstile. These when you enter something, you have to go through this turning thing, and one person at a time, and so forth. The auto reset event means that whenever you call set, one person can go through. So you have, let's just say, 10 threads waiting for this event, and you call set on an auto reset event, it means one guy gets through and the gate shuts close again. You don't control which one, but only one. Whereas the manual reset event means at the point when you open the gate, all 10 of them are through in one go. You don't get to control that I can, close it halfway through. All 10 are released. And then you can call close again, but you need to open and close yourself. This is the difference between these two. Countdown events is just a thing in between where it will close itself after n number have gone through. So how can we use this? And this can actually be used to synchronize two threads extremely fine-grained. What I've done here is I have two threads running a do work thread, which basically kind of saying, set the gate, let somebody through. And then it kind of wait for a go-ahead signal. And then it writes a message providing it's not null, and then it loops and kind of set the gate again. And then I have another thread up here which kind of say, wait for the set, then set my string message, and then set go-ahead gate, which will release this thread. It will do one loop, set again, this one will then release, and then you kind of go like this by using it. Of course, it's a silly example here, but it's showing how you can have two threads doing one step at a time, and you have full control of what goes on here. At the end, I pass in the message null, which would make this loop leave, and then that thread would end. And then I want to talk about something completely different. And the reason for this is I think these multi-threaded issues are very interesting, and from here you kind of move into the task, to the await, to all the other constructs that are in the C# language. And that is a very long talk that I cannot do in 1 hour. So instead, I want to do something else. When we do these tech talks, especially in engineering excellence, which is kind of forum we have within Microsoft, we always ask people, what do you like us to talk about? And especially this one with lambdas and LINQ is something that people really would like to get a better grip of during using that in the C# language, which I'm going to talk a little bit about now. Do you guys know LINQ or use LINQ? One guy, all right. Do you know what goes on? Completely? Then I'll sit down there and no, okay, I'm just kidding. So let's just look at this one. This is a typical example of a LINQ construct or what would drive the rest of the discussion. I have a loop up here for each integer in the int range call. Int range is a function that returns an IEnumerable of int, meaning a series of integers. And the IEnumerable supports the for each construct. So I have a nice syntactical way of operating with this. So for each integer in the int range between 5 and 11, write the integer. That's pretty simple. And the int range is a function I made that returns a series of integers, namely the integers between minimum and maximum. So the expected output of this program would, of course, be the integers from 5 to 11. That's not hard to understand. What's really hard to understand here is what goes on here. Because I have a loop up here, looping the int range. So basically I have first I call the int range, that returns the range, and then I have the for each that enumerates range, and I write each integer. But how can that be? Because they've returned the range. This is also a for loop. So I have two for loops going on here. One is enumerating the range itself has a for loop. Now, how can that be? Basically, you have, this is a stack variable, the counter here, and I'm in the middle of my loop here. I return something, and then this loop kind of continues, and there's something amiss here, right? How can you have two loops at the same time operating here? And the answer, you can't. The compiler cheats and rewrites your code into something completely different. And basically, it looks like this. This is very simplistic. It doesn't look like this in the real world, but it's going to illustrate what goes on. So for each in int range, right line of this integer really gets rewritten into something completely different. Where the range is an IEnumerable, meaning it's a factory for generating a class that has a method that can return me one at a time. So the class itself sits down here. I'm sorry for the line here, but this is the int range method here that calls the yield return. But what happens instead is it calls a range enumerator that move next. So it instantiates an enumerator and it calls a move next method one at a time. Now, this one down here, the yield return, means that this entire thing turns into a state machine, a class where you can call in on the move next call, give me one integer and return. So it's not a loop. You see it as a loop, but essentially you should imagine this being a class, and the class has a state saying the last one I returned was the 5. So when I call move next, it will add 1 and check against the maximum. Otherwise, it'll just return 6 and then 7 and then 8. That turns into a non-loop one-at-a-time method, which gets called by this move next. So you see there's a lot of things going on behind the scene when we just do some very simple code. It is extremely convenient to have the compiler rewrite all this code for us. But it's also at the same time extremely important to understand exactly what goes on. Otherwise, you lose the thing meanwhile. Now, one of the important things here is that the enumerator is constructed lazily. So basically what we're doing here is when we call this range equal int range, nothing happens. We construct the enumerator, but we doesn't start to generate the integers whatsoever. When we call move next, then we'll start to generate the first integer, but only that first integer, nothing more. So if we kind of leave this loop without enumerating all the way to the end, we did not waste time by having all 5 to 11 integers generated. We get them one at a time by calling the move next. And that gets extremely important when we move forward with the other link constructs and start chaining things together. So let's try to make this a little bit more complex. Let's say I only want to do a new method here that returns only the odd integers in the int range. So basically what I do, I create a new method here called onlyOdd. The onlyOdd method takes a stream or an IEnumerable of integers. And internally here, it does an enumeration of all those integers, checking whether it's an odd number. And if it is, it returns this number, meaning that the method itself returns a new stream containing some of the integers from the original stream. So basically, I created a filtering mechanism here, okay? That means that I can change my original program to go return all the integers in the onlyOdd of the int range of 5 to 11. It's a little bit clumsy because the order here seems to be wrong, because I'm actually starting with the integer range and then I do the onlyOdd on top of that. But this is kind of what you would have done in a C program, C# program, years back. This is plain programming, no link, no magic going on here. So the problem here is that you can see how you can take one enumerator and pass into the next enumerator and have them doing things one at a time and chain them together. The problem, however, is it seems a little bit clumsy to do it like this. So it would be nice if we had a way of changing the syntax. And this is exactly what we can do. And we only have to do a little change here. If we make this onlyOdd method into a class by itself and make it an extension method, and an extension method is no magic goes on here. It's just a method that has the keyword this in front of the parameter. It's still the onlyOdd method, and everything that goes on in it is exactly the same thing as before. The this keyword is what generates an extension method. Now, since the return value, or since the parameter of this is an int, an enumerable of int, and since I put it into the this keyword, that means that now the compiler will discover whenever I have a type of IEnumerable of int, I suddenly get an onlyOdd method on that IEnumerable of int. That's what an extension method is basically doing. From the code itself, there's no change, but it allows me to do the new syntax up here. Since int range of 5 to 11 returns an IEnumerable of int, suddenly on the IEnumerable of int, I have an onlyOdd method that takes no parameters, because the parameter is identified by the result of the previous one, namely this parameter. So what we got by doing this is actually we got a nice syntax here saying we do the int range of 5 to 11, dot, from there we do the onlyOdd, and we could chain the next one down the line and so forth. So this kind of takes care of all the syntax here. Doing this was extremely easy, and also you get IntelliSense, so when you do the dot here, it will list all the method that works here, and one of them will be the onlyOdd method. which is extremely convenient. However, let's say we have a new scenario here. See what we got here. Yes. So let's say we want to do, also an only even or only primes or only whatever method here. We want to have a lot of filtering mechanisms, right? All of these filtering mechanisms would have one thing in common. They would take an input IEnumerable, they will loop over or enumerate the entire enumerable, and then do some kind of if statement in there. Would it be nice if we could generalize that into kind of a way of saying, I want to do the enumerating once, and when I get to the if statement part, can't I pass in a function that actually returns a Boolean which corresponds to having done the if statement? Okay? And that would look like this. So basically, the is_odd, I rewrote that into a method taking a single integer and just returning whether this is true. And then I can do the same thing with this even, I can do an is prime, I can do an is whatever out of this. Then I do another change. I change my extension method here. This one was earlier called only odd. Now I just make it into only of this enumerable, and then I pass in a predicate. And a predicate is, it's on the top up there, it's a function pointer that points to a method that returns a Boolean based on an integer. And then inside my loop here, where I enumerate the enumerable, I just call that method for each integer. So that, this allows me to pass .only of is_odd. Right? So I could replace is_odd with another method, is_even or is_prime, and all the other code would be exactly the same thing. So this is kind of code reuse, and you suddenly start building up a framework here, and you'll see where this is going at the end. But what we did here is we start using a function pointer or delegate in C#, pointing to a method, and we call that method in here. Otherwise, it's the same thing. The statement return n modulus 2 equals 1 was the statement that was down here. It's no magic. Exactly what we did before. We just moved the code a little around and made it more extensible. Now, the next thing is we actually figured out that this code down here suddenly has nothing to do with integers. It's just enumerating an enumerator and calling a predicate or a Boolean function. So we could actually make this totally generic by saying this operates of any type t, as long as the IEnumerable is of type t and the predicate takes a type t, meaning that it works fine with integers because we have one here which satisfies the t requirement with integer, integer, integer all the way around. But we could use this function, the only function, with any type, because the integer information is no longer leaded by the only function. The only thing that it does is it enumerates the enumerator, calls the predicate method, and yield depending on whether you got true or false. With me so far? Now this opens up for something interesting. Because it's a little bit annoying to have to write these only odd, only even, only whatever method, especially if you're only going to use them once. So how about we generate something which would allow us to do code on the fly, applying the method on the fly instead of having to declare it and call it and pass it in as a predicate. So what I do now is I remove the only odd method as a method by itself and then do an anonymous delegate, meaning an on-the-spot method. There's no change whatsoever in the resulting DLL. The code will be exactly the same as having this method down here. I'm just providing the code here, declaring an immediate or function here that returns the I and so forth. No change. This certainly looks very clumsy. Agree with me? I mean, I have to be honest, when I did this example, I had to look up the syntax. I couldn't remember. I'd never done this before, and I would never, ever do it again. It's very clumsy to do it like this. But it's just demonstrate that we can actually do code on the spot situation here. Now, if we can do that, then it's interesting doing the inline thing here. Now we come to the point of lambdas. Lambdas was basically done to generate nice syntax with on-the-spot code. So the delegate I had before is up here. That's the anonymous method. Delegate, a function taking I as an integer and return whether blah, blah, blah. So it's returning a Boolean. It automatically figures out, since I have a return method, a return statement, it figures out this must be a method that returns a value. I return something which is a Boolean expression, so the method must be returning a Boolean expression. So it implicitly figures out that this delegate returns a Boolean, and it takes the I integer as a parameter. So far, so good. The lambda looks like this. And this is another way of writing exactly the same thing that is above there. You read this by saying, given I, then return this. And it's extremely simple when you get the hang of it, because there's no magic here. This just means this is a parameter, this is one big return statement. You can actually do code, and I'll get back to that in a second, but as it is right now, this is a parameter, and you can have multiple parameters, and this is the return statement. That means that I can write my int range example from before with int range of 5,11 dot only given I return whether I modulus 2 equals 0 or 1 or whatever. Now this syntax allows me to do a lot of stuff in a very, very simple manner. So I'm calling the enumerable, the basics is still here. This one returns a method that can give me next, give me next, give me next. But it doesn't do anything by calling this itself. The only one then have a method, and inside that enumeration at the end, it will start call the give me next, what will call the give me next, what will call the give me next up the chain here. The compiler does a lot of type inferral here. Just by doing the lambda, I modulus to, okay, I must be an integer type. You can't do modulus operation on non-integral type, so it must be an integer type. At the same time, I'm returning something which have a Boolean expression, so the return value of this must be a Boolean expression. I'm passing it into something which expects an I enumerable of int, hence this must be integer type and so forth. The compiler do a lot of guesses, and if it end up with, there are two solutions for this, you'll get a compiler error. And that very, very rarely happens, because as long as you're doing stuff like this, the compiler will always be able to figure out what you did. Now, the interesting thing is now like we had this delegate before, the predicate, the delegate of the Boolean method given that you pass in an integer. You'll end up in a lot of scenarios where you need these methods taking 1, 2, or 3 parameters and returning a parameter of a given type. And these parameters has been defined as func or action in the class library of .NET. So you don't have to define a gazillion number of these methods. And they've all been defined as generic methods saying func of T1, T2, T-result. The last one is always the result. If it has a result, then it's a function. If it's an action, it only takes parameters and returns nothing. And this allows you to pass in, if you write a new method where you expect somebody to pass in a method returning a Boolean based on an integer, you can just use this one, func of int, Boolean. Then you don't have to declare your delegate anymore. You just use the in-stock generic delegate. So looking at this, we can actually make our program, I'll get back to the program in a second, just show this here. So we have here a func of int, bool, and that is equal, method is equal to a delegate. This is the anonymous method way of doing it. This is the lambda way of doing exactly the same thing. Given I, return I modulus 2 equals 0. Here's a func of int, meaning a function taking 2 integers as parameters and returning an integer. The func means the last one is a return value. You can write it in an anonymous method, or you can write it as a lambda here. When you have multiple parameters in lambda, you need to put parentheses around it. So this basically means given I, j, given the 2 parameters I and j, return the sum of those 2. So this would be a on-the-spot sum function. And then you can just imagine you have other actions here that given an integer, go do a write line of the integer, for instance. Just such a thing here, action of integer. Given an integer, write line that integer. You could put that as an extension method called output. Now you could be able to write I.output. and then that would automatically do a write line of that particular variable. So given all this, we can actually return to a program and optimize it a little bit more. So in the delegate, the explicit definition we had on the top saying I want to define a Boolean function, take an integer returning a Boolean, that one I can actually remove because the func of I, int, Boolean does exactly the same thing, t, Boolean down here. So having this done, this is the final version. And now I'm going to jump into Visual Studio and show you some fun with this. You with me so far? Yes? All right, great. So the first thing I'm going to show you is actually, we do these recruiting events like we discussed before. And one of the job, I'm going to give you one away here. One of the job interview questions that one of my colleagues used, I'm not going to give you my own, no. One of the ones that my college used was, given that you have a stream of characters, write an algorithm that can either count the number of words in that stream of characters or return the 11th word of that stream. That was the task at hand here. So what I did, I kind of took that and said, I can actually play with this. So let me just... I did a large file, large doc.txt. This is just some random text I picked up from a white paper. So this is my stream of characters sitting currently in a text file. It's several megabytes. It's huge. So the solution to the first one, the word counter, actually is here. It's nothing more than this. This particular program reads in, let me just show you. This particular program reads in this large text. There's a one-liner to do that called file.readAllText that returns a string. And this little beauty here then takes that string and then count how many words are there. Basically by establishing a small state machine doing, as long as I get letters, I think it's a word. And when I get nothing that is neither letter or digit, then now I'm in white space mode. And then I just keep looping over all the white space. So I'm only interested in the point where I go from being in letter mode into white space mode. That constitutes a word. And that's basically what I'm doing here. Do all the characters here, figure out whether it's a letter or digit, check whether I change mode from letter into non-letter. And if that happens, and I was and I have a letter now, then I have another word. And then just say what the last one was. So basically, the very simple algorithm that will count the word in this entire file. And we just run it just for completeness. So I set this as a starter project, and then I run it. This is actually pretty boring, and it ends up counting 1,400,000 words. Pretty uninteresting. And then I kind of went, now, you know what? I'm going to do some Lambda examples, so why not use this one? And then go berserk, which we're then going to do. So the first one, oh, how annoying. The first thing I did was to write an enumerator. So this code here does the same thing as before in the word counter. It takes a string, but now you notice some of the thing we just saw before. It takes an I-enumerable of characters, and then it returns an I-enumerable of words. So basically, the code here goes for each character in the characters. Do the same thing before, as long as we are doing letters or digits appended to a string builder, meaning pick up all the characters until the point where you get a white space. When you get a white space, then check whether you got something in the word, and if you did, then yield return this one, meaning return the first word out of the enumerator. So what I have here, and then at the end you return the last word. What I have here is an enumerator that can be passed in all that text you saw before, and then every time I call it for each, I get a word out of it. And that actually allows me to do some pretty cool stuff. If you do this at your job interview, immediately hired. Anyways, so let's look at it here. So I prepared a small program here. So this one has the basics here. So basically this is doing read all text into the string, and then it does the IEnumerable of string called words, is now the doc.words. That's my extension method. Dot, and then I call to array to kind of save it. Instead of calling this extension method on every axis, I kind of cache the result, and now I can use the result on what I'm going to do further down. Now the first thing we can do would just be to print all the words. And printing the words is pretty easy. That would just be for each string word in words console dot write line of the word. If we run this, that would just output all the words, one at a time. Oh, I'm still at the other program, sorry. So this one's a starter project. So what we're getting out of this is now the enumerator of characters yield words one at a time that gets printed, one at a time on the line here. It's basically pretty boring. But it just means that I have an enumerator of the word. And that means having this set up, I'm ready for the Microsoft interview, because the first one would be, what is the number of words that you have inside this document? That's pretty easy, because now I have a lot of these extensibility methods in the framework that can help me do what I want to do. So the count is words dot, and notice I get a lot of methods I can do on this IEnumerable. This is all the extension methods that are built into the .NET framework, and one of them, ta-da, is count. So what this one does is basically just do a for each and count how many times could I for each on this one, and then return that as an integer. And surprisingly enough, this will end up returning the same thing as my word counter did before, 1,400,000 something. That was the easy one. Now, the next one would be true words. So let's say I want to know all the words that actually start with a letter. So all the one that starts with, it was digits or letter that I checked for before. I want all the one that only starts with letters. So to get that one, I would do words dot, and now I need a filtering mechanism like the only before. I only want the where, only want the one where, given a word, the first character of the word is a letter. Dot count. Let's see if I'm missing something here. There we go. All right, are you with me so far? So I do all the words, I do the filtering mechanism that takes the IEnumerable of all my words, filter out only the ones where the first one is a letter, and then return a new enumerable, and then I call count of that one. So this will give me a new number, which should be the number of words in my file that starts with a letter. And that turns out to be 1,300,000 something. Right, so something was missing here. Now the next one is, give me the largest word. And if you imagine writing the code for, even if I have the array or enumerable of all these words, if I were to kind of say, give me the largest word, the longest one, which one is that? And how long is it, by the way? How would we do that? How can we do the largest word? Well, let's say the requirement is just to get the longest one. That would kind of be a, enumerate all the words, have a max length, and then go figure out. But this is already built into the framework like the only function I did before. Somebody wrote this method that enumerates and do a function here. So it's kind of only words dot maximum of, given a single word, I want to return the length of this particular word. What this does is it passes in a function. This, given a word, that's a function taking a string and returning the length of the string. And then the max function simply does a enumeration, calling the function for each word, getting the integer back, and keeping track of where I get the maximum integer, and then eventually returning that one. Just like the only function I had before. But all I'm showing now is standard functionality right out of the box. So let's see what the longest words is, and I recall it's 27 or something. 26. So the longest words in that stream was a 26 long letter word. All right, well, that's not that cool. Let's see something else. How many different words are there? Now, this is one lousy one to write manually. So, how many unique words are there in this particular stream of words? But of course, there's also functionality from this. It's called distinct. So this one will return a distinct stream of all these words. Dot, and then of course do the count of all the words in the distinct stream. So the distinct stream will take all my words and make sure each unique word is only returned once. But then I count that stream, and then I have the number of unique words out of this thing. So I get the different number of words in this stream is, let's see, 1,755. It's actually interesting. You write a megabyte document, you only use 1,700 different words. So it's only a one-liner to do a lot of these things. The next one. Now, give me the word 1,000. This is one of the interview questions, so I'm definitely going to bassel the interviewer here. So not only give him the nth word, I'm going to give him 10 words in the middle of this particular thing. And, of course, there's also functionality to do such a thing. So we go for each string word in words dot. Start by skipping the first 1,000. If you skip, that means this is a function that takes an enumerable of words and just loop over the first 1,000, ignoring them, and then start returning the rest of the stream. And then we have a limiting function saying take. That means whatever is in there, do not return more than the 10 first words, or the 10 first of the stream, and then return I'm done. And with this, then do a console dot write line of that particular word. So this should return the words 10,001 to 10,010 in the stream, and you'll see some words here. It just happen to be Microsoft Dynamics NAV, which is the product we're working on. Ta-da. Anyways. Now, even more interesting is, that was one of the questions before that Michael was talking about, the 10 most used words. Now this is going to be ugly, right? So basically what we're asking for here is, you need to find all the distinct words, you need to count the number of times it's used in that particular thing, and then return the 10 most used ones. Can you think about the algorithm writing that in normal code? It's not like it takes 1,000 lines, but it's pretty tough to do that. Of course, in LINQ, it's a one-liner. So we'll do a for each. So again, now we want to return both the words, and we want to return the frequency of how often those words are used. So what we need to do is basically get all the distinct words, but we need to group them. We need to group them by a distinct word, and then figure out how many words that falls into each distinct category. And the distinct category is the word itself. All right? So that means that what we end up with is a group. But I'll get back to that in a second. In words dot. So we do a group by, given the word that comes in, I need to group by something. What is the distinct value I want to extract from this word? But that's actually the word itself, meaning I will get as many buckets as I have words, distinct words, and now I just need for each of them to count how many words falls into each bucket, right? So this one will return a series of objects where I have the word itself, and then I have a stream of all the things that are in that bucket. So after I have this one, I want to order them because I want to have the 10 most used ones. So I go order by descending. And then I take, given that I have a group, I want to order them by group.count, the count of words that are in that group. And after I've done this, I want to take only the top 10. And from this, I can do console. Dot write line off. And let's say we want the word first, or the frequency first, so we go group.count. That was the number of words plus a space plus group.key, which is the key of the grouping I did over here with this group here. But eventually what you get here is a one-liner which does exactly what Michael was asking for before, and this is the frequency of all the used words here. And again, here you have the 10 most used words in this text is the word is used 42,000 times and so forth. It's pretty goddamn awesome. I'm good at this, actually, by the way. So, the last one I want to show you is what you can do also. Now, let's say you want to use this for a silly thing, like implementing a spell checker. So, if I do something like this, I do a hash set of strings. Meaning this is the list of all the words I have in my spell check dictionary. So we call this spell check. So this is all the words I know in my spell check. I initialize this with a new hash set of string, and here I can actually have different overloads, an empty one, but I also have one which happens to take an enumerable of strings. Wait a second, I have all my words sitting here .distinct. That is the list of all the distinct words that I have in my text. So now I have a hash set, a quick lookup mechanism of all possible words that I know. I only know the words in my document, so it's going to be a little bit boring, this one. Then my spell check algorithm would actually be pretty easy. Let's say I just want the int errors. The number of errors, meaning that is all the words I can find in my document which just happens not to be in my hash set. This is my very poor man's spell check here, right? And that just means that I need the words dot count, no, dot where. And then I need to do a lookup. Given that I have a word, I need to make sure that I have a condition where not my spell check dot contains my particular word. Dot count. So this one actually, this one-liner implements a spell check across my word, because this one will take every word I find in my entire text, and then will be filtered by the condition where, given a word, I cannot find it in my spell check hash set, right? Of course, if I run this, we can just run the console.writeLine of errors, right? Something like this. Let's see what happens here. The surprising fact here should be a 0, right? Because I'm feeding the thing with my own words. So I'll probably get error 0, so there's no mismatch here. But what happens if I just remove one of the words here? So what I can do is I can go and say, after I create the spell check, I go spell check dot remove of the word the. Now this should generate some errors, because now the word the is not in the mode. You get where this is going, so let's see where we get with this. So what happens now is that it will go look up into the hash set and it will find a lot of errors. Namely, it will find 42,000 errors, which just happens to be the number of the occurrences of the in the text. So in one line, wrote a spell check mechanism, which is extremely easy. I'm pretty sure that if you showed this as a job interview, I would hire you, right? And that actually completes what I have to tell you today. Thank you for listening.